Find the domain of the function x plus 5 over 7x minus 6. This is a rational function and we cannot have 0 on the bottom. But we can have 0 on the top. There is no problem. But we should not have 0 on the bottom. So we want 7x minus 6 not equal to 0. This should not be 0. Let's find the value of x that makes this 0. Okay, add 6 both sides, divide by 7, so 6 over 7. So x should not be equal to 6 over 7. So when we write down this domain all real numbers, we should not have 6 over 7. That's somewhere here. 6 over 7 should be avoided. That means the domain in terms of interval notation is negative infinity through 6 over 7 and 6 over 7 through positive infinity. Let's move to the next question. Again, same thing. We have no problem on the top. The top is allowed to be 0, but we should not have 0 on the bottom. So x squared minus 9 should not be equal to 0. Move 9 over, x squared equals 9, not equals 9. Take square root both sides. Then by square root property we get plus minus square root of 9, which is 3. So x should not be equal to plus minus 3. So on this number line, set of real numbers, we should not have negative 3 and we should not have positive 3. So the domain is negative infinity through negative 3 union negative 3 through 3 and 3 through infinity. Okay, in this way we avoided negative 3 and 3. 32. Find the domain of the function. So we have a square root and we know a square root of non-negative numbers are defined. So this number 3x plus 4, that should be bigger than equal to 0. A square root of 0 is fine, that's not a problem. But a square root of negative number, we get imaginary number. That's not good. So we should have, we want to have 3x plus 4 bigger than or equal to 0. Okay, 0 is not a problem because the square root of 0 is 0. Solve for x, subtract 4 from both sides, subtract 4, divide by 3. So x should be bigger than equal to negative 4/3. So negative 4/3 somewhere, negative 4/3, and bigger means on the right, and including negative 4/3. So the domain is all reals bigger than equal to negative 4/3. So domain in terms of interval notation, negative 4/3 and bigger all the way, infinity. Okay, let's move to 33. Find the domain of the function. We should not have 0 on the bottom and there's a square root, so inside x minus 2, that should be bigger than or equal to 0. 0 on the top is fine, the square root of 0 is 0, that's all right. So x minus 2 should be bigger than or equal to 0. Okay, that means add 2 both sides, so x should be bigger than or equal to 2. That's coming from the top. And bottom, we should not have 0 on the bottom, so x minus 3 should not be equal to 0. That means add 3 both sides, so x should not be equal to 3. So on this real number line, negative infinity through positive infinity, x should be bigger than or equal to 2. So here's somewhere 2 and bigger. 2 and bigger. At the same time, x should not be equal to 3. So 3 is here, so we need to avoid that part. Okay, so the domain in terms of interval notation, starting 2 to 3, 2 is included, but we should not have 3, so parenthesis union 3 through all the way. Okay, when we write parentheses, that is not included. Number 34, x minus 7 on the top, no problem, we can have 7 minus 7 0, that's all right, there is no trouble. On the bottom we should have for this square root to be defined, we should have x plus 8 bigger than equal to 0. If this is bigger than equal to 0, then square root of bigger than equal to 0 is good. But due to the location, we cannot have 0. Square root of 0 equals 0, that's defined, but something over 0 is undefined, so we cannot have equal to sign in this case. Okay, we should have x plus 8 strictly bigger than 0. Okay, it is different than the previous case. In number 33 we had a square root on the top, so 0 on the top is allowed, so x minus 2 bigger than equal to 0, but we cannot have 0 on the bottom, so in this case x plus 8 strictly bigger than 0, that is same as x, subtract 8 from both sides, so bigger than negative 8. So on this number line, negative 8 somewhere here, and x is bigger than, strictly bigger than, so parentheses, and so the domain is negative 8 through negative 8 through all the way to infinity. Final.